and thank you for listening to our presentation. And we have 5 presentations today, and then 3 in the morning, and then we take a break and for the 2 more presentation. The topic is cover about inclusive innovation and technology and community empowerment and cover on sustainable development also. Thank you so much. Please enjoy our presentation. Thank you.
The first speaker, Dr. Jong Moon Moon, is correct? I don't know. He's the chair of the Asia Pacific Research Platform. Thank you very much to accept our invitation. It's from the Korea Institute of Science and Technology Information, Christie. So the floor is yours. His title will be Utilization and Requirement of Research Platform for Applied Research Field. So if you want to know more, there's a lot of session on Wednesday.
Yeah,
Yeah. Right.
Yes.
Thanks for you.
Hi. Hello, my name is Jung Moon, as mentioned before, and I came from Korea. KST. The KST is the representative, the government-funded institute in Korea, and we have 2 types in major world is supercomputing center and National Research Network Center. So today, I'm going to introduce the research platform. The research platform meaning is the currently the popular keyword for the scientific areas, and the title is Utilization the Requirement of Research Platforms for Applied Research Field. And I understanding this working group is agriculture and the combination with the digital areas. So this platform is very beneficiary for those areas, how to analysis, how to the calculate in the near future. It's kind of the running the AI or the running CPU, the running the memory intensive systems for both areas. So anyway, thank you for inviting me to giving a chance to presentation this year. So this is a long-term vision from the plan built by the San Diego Supercomputing Centers in the UCSD. And all those kind of the technologies belong to this open science. The open science is the occurs 10 or 15 years ago for scientific areas, but the currently I think it's 5 or around the years ago, the actual environment established from the US and the neighbor countries. So the open science is the divided into the 3 or 4 topics very important: open data, open source, and open infrastructure. So open infrastructures include this open computer, open storage, the open CDN, and the open device, open instrument, and the open IoT, and all those kind of technologies or areas is combination with open. So the close areas comes from very tightly a very concrete situation from the commercial areas, but the scientific areas is always open for this kind of the public. So openness is for an open society is very important keyword, and the research platform and the AI, the running model, and some kind of all technologies belong to this open science. And we focus on the how to is the better open science strategy or open science technology. So today I want to explain about the 3 the big areas. So what kind of the activities in the globally from the globally and the research platform, and then the how to the deploy this the third party research areas, and how about this Korean situation, and what kind of the project running on Asia areas. And so and first of all, I want to introduce the global trend of the distributed HPC with the big impact. And the research platform is, again, the definition, the high bandwidth distributed HPC. And it means that this high bandwidth is supported by this global the research network and distributed HPC. And it's as a complication, this definition. So the many, the big country, advanced country, they have their own the supercomputer. But the supercomputing technology and the supercomputing capacity or the ability is kind of the very big higher positions to not permit to another country, because the currently globally and the concentrate and the focus on this AI learning or the LLM or the deep learning or machine learning, and the very essential technology or infrastructure using supercomputing or something like that. So the most of the advanced countries is they don't want to share the computing resources to neighbor countries. So at that time, and we announced and we introduced and the suggestion that how to make this the distributed environment. It comes from say 10 or 15 years ago, the grid project. The grid project from the Iowa National Laboratory in the US, and they already made this a global or something like that. But 20 years ago, 15 years ago, they didn't show this the actual the environment or actual machine. But currently, and grid the theology or the grid the philosophy is became such like environment research platform or the high bandwidth distributed HPC. And I can tell you the distributed HPC is separated, divided into the several the major community or the major the topics: NRP, GRP, APRP, KRP. The ARP is Australia the research platform, and some several topics, and it's kind of the XRP. And I introduced this briefly. The National Research Platform comes from the US. It is a partnership with more than 50 institutions. It's led by the researchers and the cyber infrastructures professionally at UC San Diego, supported in the part by or from this National Science Foundations. This project comes from around 2015 and between 2020. And the first name is PRP, Perspective Research Platform. They started at the California state. It's kind of the first time is how to cover the whole US continental. So the main is the system power is the name is Nautilus. It's kind of the cluster system. And the research platform is improve and how to share, how to using a distributed environment. The essential keyword and the technology is how to build this high bandwidth network. And the US campus and the national research labs is connected among this over 100 gigabps networks. And they assume that is the exchange point and it's very essential to running this distributed environment. And all NIP and the PRP comes from those technologies areas. So National Research Platform is divided is four the US continental and the four the supercomputing centers by the NSF or by the DOE. And they get the funding, they got the funding 5 years with the 4.8 million hardware and the $6.45 million papers support Nautilus and the core, the NRP infrastructure. And this infrastructure is the connectivity in the visual mode. And all the content, those over 90% is the systems is located in US. And is the red circle is Korea. And some the below the point is Guam, and the behind is the hidden the small picture in Australia and some other countries. And the US NSF and the UC San Diego is wanting to make this as a gather the small machines power and make the big one thing to solve this big problem, and based on this AI or the computational areas. So this is the other and the maps. And in the middle of the box is the blue circle is Korea system is already involved this from 1915. We were 2 or more this involved with this infrastructure. And this is the monetary environment. The NRP system is based on the multi-cluster system. They have already it's over 1,000 CPU core. And the red circles is focused on this for the medical areas is the using the CPU and the GPU powers. All things is over 20,000 is a GPU core and 60,000 is the CPU core, and many devices is attached to those infrastructure. And many users is access to this Kubernetes interface, and they ask this, I want is how many CPU, how many GPU, how many the storage, and how many the memory, and UCSD and the San Diego supercomputer support through this Kubernetes through the request the researchers they using and the some and or 6 months or 3 months or over 1 year, and they after finish their work and they return to all open source the multi-cluster system. And this is the another the consortium is the name is the GRP, Global Research Network. The NRP is a focus on the US, and the global research platform the focus on the globally. And there the readers is wanted to the gather this the distributed the research platform communities such like KRP and the APRP and the NRP and the ERP and something like that. And many the scientific domains and based on the network or based on storage center, and they can join this big research platform environment as the distributed node. This is the main participant researchers from the globally. And I want to explain about this the APAN, the APIP working group. APAN APIP working group since 2018, and our focus and objective is to develop the technology to provide the data intensive science such like HPC, astronomy, science, AI, and the bio, and the climate, weather, and agriculture, and so on. And those environment and the various computing by the linking distributed HPC system and establishing a stable big data high rate system on NLAN in the big data era, and promote the related research collaboration in the Asia areas. And we can divide the topics to promote this distributed shared HPC ecosystem in the Asia Pacific areas. And our problem is very obvious. We have a lot of the smart brain, but we don't have enough of the IT infra or IT resource. And the APIP wanted to deploy how can the resolve the lack of IT infrastructure, lack of IT power. And so it means that it's a supercomputing power. Supercomputing power is, as I mentioned before, and the advanced country is kind of the indicator. They don't want to share any power of the supercomputing or the computing or IT. But APAN and our all kind of our members comes from this non-profit, the research institute or something like that. So the API will focus on how to promote distribute and share the HPC environment in Asia areas. So and we have the two there's branchy and the international, the project or the one is already done and the other is running now. And as you know, this the APAN, the APIP working group is 2 times in a year. The last year, and we had this the 58 and where Pakistan, Islamabad, and in this year, this in the March, and we had this Yokohama in Japan. We have 2 sessions or the 3 sessions, the 12 or the 14, and the presenters from the 6 or the 8 countries. And we every year we update the country status and the country environment and how to collaboration our technology and deploy for the third party applied research areas. And the real main topic is the bigger and the bigger, wider and wider, and the last time and the wireless and the science imaging NLP. Sometimes we handle this quantum computing and the quantum security. So this is our example of the presentation. And this is the ASEAN Pacific Research Platform. We have actual machines set up at the UPM in Malaysia the last 2 years. And ASEAN Connect project, we collaboration between Pakistan, Malaysia, Korea, Australia, and we set up the 3 or 4 nodes established in the UPM, the system room, and connected internet network, ASEAN Connect network, and we're running in the basic state and staging. And I want to introduce Korea Research Platform. And the Korea Research Platform is since 2015, and we became as a global partner of PRP and the NIP. And since 1918, there's leading the APAN, the APRP working group. And in 2021, they expanding to the 7 Korean National Research Institute. And the KIST is already, I comes from as a Korean. The Korean is meaning as a Korea research oriented education network in Korea, and the representative of the research network in Korea. So our members in Korea is over 200 the institute and the university. And we have the government, the funded the research institute is over 25, and 7 research institute of 25, we already set up this research platform and connected with, well, it's a network. And since 2022, the ASEAN Connect project, by the 10cc for international collaboration 4 countries. And the last year that we get the fund from the A3 to the 4 site in the program project by A3 countries and the research, National Research Foundation. And A3 countries, Korea, China, Japan, we focused on this, how to collaborate supercomputing infrastructure for Northeast Asia. So our final goal is to establish the high reliability and the high speed transfer system without boundaries between participants. The many institutions is the big barrier to communicate with the other institute or the other university because the security policy. And in case of Korea, we divided the North and the South Korea. The Korea CIA is very strong pressure to open our network and the collaboration with the other institute because they don't want to the anonymous or just the open. And we have this the correct proposal why we combination, why we collaboration with others. So very strong the security environment, but we couldn't do it through this CareerNet, and because we handled our research environment. So we the step is just a step 1 around the 2 area around the relocated. Our final goal is There's no security pressure, the no boundaries, the collaborative our neighbors. So this is based on the actual machine experience. The Korea, the research platform expanding to the 25 National Research Institute. They are final goal. It's kind of a dream. The HPC and the ICANN, the including the supercomputer and the cloud and the storage and some other analysis machines. And as a technology, the aspect I can say that HPC over APN, the high bandwidth distributed HPC. The facilities are the belong to this KST. This is our the KRP research platforms is a status. We build is a small research platform and the internal architecture and those two the rectangle images the interface in the status the monitoring environment and we using the open sources that make the research platform. And this is a location, position, location, and our the server room, and there's the architecture in the server room. And this is the basically technology, how to the connectivity with the the neighbors institute or university. This is the how to build this node, the 7 research institute and the bio and the fusion and the aerospace and the chemistry and the university and the energy areas. So this is how to share each university or the institute donated the resource very partially, and we together through the high-speed network and managing KST through this Kubernetes and support to the third-party researchers to what they want the computing resource. And this is the small examples is using our platform. This is urban flooding situations, and the right side is the blue, the red areas is the very big disaster in the small areas, and this picture is after is a big barrier against the flooding, and currently is no the victims or there's no the errors in those areas. So the climate and the disaster researchers is they have data, they have a model, but they don't have enough AI machine or a GPU or computing power, and we support this environment to running their jobs. So this is the proposal and the implementations is for the agriculture field and the crowd model and some learning and their analysis or the forecast that they're the next blah blah blah. So this is more the technically in the agriculture areas is the required to us is how to the running is ensemble situation. The ensemble environment is the model A and the running and the research platform and the model A to produce the intermediate the result. And this intermediate result is should be the putting another model type B, and they want to make is the combination the several models so automatically. So nobody can support, and because in the commercial areas is not make the big money. So non-profit areas such like KST support those technology on our research platform, and the basic it's kind of the prototype. This we can show there's a possibility to the rural department in government, and this is architecture or some decision-making system. The many disaster situations is occurs at the same time, typhoon and the big flooding and the hot weather, and how the minister or how the officials decide this is disaster or not disaster. They don't want to take this responsibility, their decision. So this system is the a little bit help to the this is decision not this is digester or not digester, and based on this IT analysis. This is a focus on the medical areas, and through these two topics is Asia Connect project, as I mentioned before, and the motivation is increasing big data, require the high throughput and the capacity network, and it became as a big data transfer highway. And the lack of IT infrastructure is the required this compute resource, and it means that this distributed, the shared HPCs is necessary for those areas. And the link the science team is, it means that the link is the big data cross point areas, and the research platform plus its Kubernetes is high bandwidth distributed HPC environment. Not easy, but it's very the challengeable areas. And this is the whole the concept of the Asia Connect project is we collaborate with Australia, Korea, Pakistan, and Malaysia. Malaysia is a support for the biotechnology, and Pakistan is donated for the AI technology. Australia and Korea is donated the country, and we helping our experience the set of this system and the running system and to deploy those two countries. But at that time, it's Pakistan, they had this big disaster, big flooding, and around 70% of the nationwide is very big disaster situation. So all our machines have to set up this in Ukraine. And this is our strategy, building a big data superhighway based on TAIN, and a second strategy, building a distributed HPC platform, and third is presenting piping user cases. This is the how-to, the connectivity, and then share areas. This is monitoring system. This is the research platforms is the pseudo architecture. The component or CPU, GPU, and the memory. This is the same the architecture, the research platforms at the UPM machine. And this is the activity, the images. Okay, this is AI running on our machine, and our activity through this Asia Connect project. The HCP4 science project is we combination with the Korea, China, Japan. In case of China, is Guangzhou Regional Computing Center from the Sun Yat-sen University, and in case of Japan, it's the Riken Institute. Riken Institute is handled as K computer, and currently, I'm not sure the next K computer next version is the more powerful. I'm not sure. And the KISTI, the three institutes is the handle this supercomputing. So in my case, I embarked with this project as the set of this big data superhighway between three countries. In case of China, is how to share the supercomputing infrastructure, and in case of Japan, is how to the big data compression by AI technology. So this is our the image how to deploy. And then this is the role of the separate our role, the unit 1, 2, 3, 4, and each country and the institute take each the unit, and this project is the 5 years in the stage 1 and the 2. The 1 is the 3 year, 2 stage 2 is 2 years, and we concentrate each part is their experience. So, and I almost finishing. And this is KISTI. This is the first kickoff meeting. Anyway, the why I explain about is those technology and the agriculture and the disaster areas is really the actual big user using super IT infrastructure.
Mm.
And I came from this IT area, and I always we always is looking for this third party application areas, what they want, what kind of barriers exist in your areas, and how to resolve this problem.
Mm.
Currently, the globally, the advanced countries, they want to get the next the authority to handle the global as AI technology or the computing power. So APAN and the non-profit institutes want to make this connectivity each other amongst our knowledge and our the resources, such like through the research platforms. Thank you for listening my talking.
Thank you very much, Dr. Moon. Any question? Dr. Moon? Yes, Basaki.
Okay, my name is Basuki from Indonesia. Thank you for your presentation. Okay, you have so many, resource for the computation and maybe for the storage capacity and network. Okay, did you have any use case for hosting or for processing the data from the agriculture, like from the
Yes.
weather station or from the crops
Yes,
or from the
important questions.
decision?
And we already, since 2 years, 3 years ago, in collaboration with the Seoul National University, the agriculture, running the developed as a crop model. So, and they need this climate data and weather data, and they running their the crop model, but they don't, they don't have the computing resources. So we the collaboration, we made the collaboration, the project with the Seoul National University, and he studied and researched their jobs running on our machines. But currently there is the small size, and so we want to showing there is a possibility. So we want to make the big one thing, and we want to make this a big fund to deploy the agriculture or disaster and the climate weather areas. But not easy to persuade our government or the funding source. So currently, I obviously can tell you that we in collaboration with those areas, but I'm not sure there's a detail or the exact keyword, what kind of keyword we're working on. I just crop model or ensemble model or the weather data and something like that. But they reply to me is very essential, and they wanted more collaboration with us, and we currently finding the new funding source.
Yeah, is that you like manage the satellite data? Usually the satellite data monitor like a crops.
Yeah.
Crops crops prediction, or if there is something disease perhaps with the cloud, and then the satellite from the
Yeah.
cloud, and then you can build a model, and perhaps you have some
Yeah, that's right.
predictive model for the
The satellite data and those kind of all data sets is belong to this agriculture or weather areas. So someone says, let me know that this the exact point, the exact location, and announce the contact point. I can negotiation, so we can the collaboration, and we can connect with those areas, and then we communicated all data and import our system and running and storing and archiving and something like that. So it's but in my opinion, in my experience, is not really found to this the exact is a contact point, and then the many the third party researchers is some of them is very small. A few people is ready to the collaboration with the IT areas. Most of the officials and institute not yet to collaboration with the IT areas. They status is very lower level. So that is our problems to communicate with them. Okay.
Thank you, Dr. Moon. It's a very nice presentation and information. Just I want to ask that, as you mentioned that weather area is probably the more prominent one in this global research platform. But what is the possibility of focusing on other areas, like we have different varieties of agriculture, then soil types, and well, there are so many other areas that we may have to look into when you think about improving the productivity. So how do you proceed with to focusing on different domains of agriculture?
Yes, I can say there's two types. Is one is in case of the APIP working group, and we already collaboration the AI area and the bio area. It's already we collaborated with the neighbor countries. And currently we not yet to communicate with the agriculture international researchers, such like this working group, and we focus on this collaboration with the Korean domestic. So the research, the climate and the weather, the expertise is they can the analysis is Asia areas learning their model. So we want to make this the big procedure and the big the agenda, make the big agenda to announce these areas and the gathering these collaborators. Okay, yeah. Talk more.
Alright, okay, thank you. Yes, okay. It's one question, okay. The discussion will be on the second session, so please stay, to do the collaboration or anything, but.
Excuse me,
Yeah.
Stay.
we have been discussing and then with the Korean Society of Coastal
Yes.
Science. Have you heard? It's
Yes,
about
yes, she. Yang Sudina.
we call him Jay.
Yeah, I'm not sure. Yeah, and then
And they will arrange a conference in Thailand on the 27th to 28th. There are a lot of member countries. Maybe the coastal area is the area that I think we need an HPC to support in case of for the climate change information. If we get a chance to meet them again, maybe we will discuss all this, just to let you know.
yeah. Oh,
Thank you.
yeah. I just comment. I understand. So that was you. Tomorrow.
Okay, talk more in the second session, it's much easier. And
When?
no, that's after this,
Okay,
and then it's just the break, and then the break will be in the room, I believe. Right, the break will be in the room, so we can continue. You can, when the break come, just go get the break, and we can continue. Really depend on Eileen. You're the next one, please set it up. The next speaker is from Philippines. Her name is, let me see, Eileen Sabio from UP Diliman. And her topic will be design of multi-period flood distribution network with